All right. You'll note that assignment 1 is posted. If you go to the website, this is particularly true for Chrome. If you go to the main website and you scroll down under assignments and you see nothing there, it's there on mine. It's because your browser is cached like an old version and it's loading an old version of the website, not the actual live one. So just refresh it and it'll pop up. Note that there was, and it's happening to me too, if you're using Google Chrome and you try to download these things, and I added a warning about it, I'm going to add an image after class. If you click this, and it says like, oh no, like I can't be downloaded, it's not secure, you can just say like, okay, and then you'll get it anyways. The reason it's saying it's not secure is because it's like a script, right? And those scripts can run, and if they are malicious, they can cause quite a bit of trouble on your computer, but the scripts I'm giving you are just fine. So it's Google Chrome just being super safe and not making sure you know that you want to download it before you actually download it. So that'll take care of that. If you're using other browsers, I haven't tested it on Safari, but if you're using Firefox or Microsoft Edge or Explorer, it worked just fine. You didn't have to do the extra steps. Note that the assignment is due in 2 weeks from now. It would typically be due on Mondays, but that Monday, the 12th, is Thanksgiving, so I'm not going to have it due on Thanksgiving. That's way too mean. And what else? As of right now, we haven't covered all the topics that you need for that assignment. We've covered most of them. But we will be covering the last little bit very, 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 very soon. Any questions before I get going? Okay. Cool. All right, so we ended on this point last time. Functions can return values, and this is what like the lab last week was all about too. Functions can return values. Whether or not you tell a function to explicitly return a value, all functions are actually going to return something. If you don't write a return, who here remembers what Python does for us? What do you say?
The last line?
Like it adds in a last line that we don't see, and it says return, and then there's nothing there. And when that happens, the function does return something, but it returns a very special value that signifies to Python and you as the programmer that, oh, there's nothing there. So it's not literally nothing, it's a thing that means nothing, like a symbol. Just like a stop sign isn't the manifestation of stop, but it's a symbol that means, oh, I stop. So we get this special object, this thing that tells us it's nothing. So if you remember, we had a function called doStuff. We wrote this like in a couple, like if I scroll up on the on the web page, you'll see this little function. What is it doing? Well, this function is called doStuff. It takes an A and a B. Remember, that's just the definition. When we call the function, that's when we assign values. I haven't called any of these functions here. So it's a function that takes two parameters, A and B. Why A and B? I don't know, I just picked them. Could have called them whatever I wanted, minus the constraints. Then I say C equals B times 2, then D equals A plus 4 times do, and then C, we overwrite C, is D plus C, and then we return C. I don't know, like, whatever. Don't think too hard about what is this function doing. Who cares? It's just a little bit of math. It's doing this calculation. And then at the end, it's not printing out a value, is it? What is it doing? It's returning the value of C. Whatever value the variable C has, it's giving back to me. So I'm about to call this function. I'm going to go right here and say A equals doStuff and 5 and 6. Great, there, I called it. I didn't print anything out, but I called it. And what it did is it did the calculation, and then it returned the value of C. And then, when I call it down there, doStuff at 5, 6, okay, returns the value of C, I put that in A. Whatever value C has, where is it after I run this line of code? Where did I put it? Somebody yell it out. No ideas? Where'd the value go? Into A. And we can test this. Print A. It's 30. We put the value that that function calculated and then returned into A. Why? Well, because that's what it's telling us. The function returns the value C. So once we call do stuff in that box right above the print, we say do stuff 5, 6. It does all the calculations. It does all that math. And then it gives the number back to wherever I called it from, which is in that box right there. So it evaluates the function returns a value, and then I immediately put it into A. And then below I print out A. I don't have to assign it to something. I can just print it out immediately if I wanted, I guess. 30. But when I return the value A, I can do something like this. I can use that value. Now it's 31. Why? Well, we know A was 30. And then what's A plus 1? 31. If you're scratching your head, you're probably thinking too hard. Questions about this now. Judging from how quiet it was in here when I was asking the questions, it makes me think that there's some uncertainty. So please ask the question, because if you have a question, chances are half the people in the room have the same question. Any thoughts, questions, concerns, comments about this? Yeah?
What are the values for the other variables?
When? See, that's a good question, but then I have to ask when. Presumably you mean...
Like a C equals C, like what's the point pattern there? Let's play D. Never mind.
D is just a temporary holder, because then we're using D to add to C. But when I call this right here, when I run this code, I just hit run, 5 and 6, it calls this function. What value does A get? Okay. What value does this A get? 5. What value does this B get? 6. So what is B times 2? 12. So we put 12 into C. What is A, which was 5, plus 4 times 2? 5 plus 4 is 9 times 2, 18. Perfect. So we have, what was it? 12 and 18. What is 18 plus 12? We put it into C. We have 30. Return it. Then this A gets the value 30. And do note that this A and this A are entirely different A's, but more on that in one moment. Good question. But here, I can then call this function again. Let's do B equals do stuff and give it like 1 and 2. Well, now what value? On this line right here, what value did the A take? 1. What value did the B take? 2. Why? Well, because it just matches. The first one and the first one, the second one and the second one. That's it. That was a good question, though. Any other questions about it? Yeah?
What exactly is the return doing?
It just means once I'm done this function, I've got this, like in this case, I've got this value C. Okay? And it took on 30, right? Because we did all the calculations. So the value, it's 30. Now, as of right now, that function and the variable inside that function called C is the only thing in this program that knows about that 30 that we just calculated. So pretend you're the function. You did all that calculation, and you've got this variable C in your hand, and it's got the value 30. I called you. I said, hey, here, take 5 and 6, do this calculation. Then, once you get the 30, you're going to return that value to me. Because I called you. Pretend I'm the line of code, that A, where we've got that 10. It says line 1, A equals do stuff 5, 6. You give it back to me, and it goes to that line of code, and then we immediately put it into that A. It gives it back to me. Now, if we go here, what's the difference between this function and this function? Well, 1, its name, and 2, it doesn't have a return, it has a print. Let's see what happens if I change this. Before I change it, I'm going to hit run. I'm going to delete this right here. I hit run. What output did these 2 lines of code generate? Nothing. We didn't see anything, right? Yes?
But it returned it because it automatically did it.
Well, it returned it because we told it to return. It said return. I'm going to change this to no stuff. And I'm going to hit run, and let's see what happens. Well, it generated the output 30 and 14. Why? Well, because right there in the box above on line 5, it says print out the value. We printed out the value. Print and return are so different. So, since that function, no stuff, printed out the value, and I didn't write any return there, what value, here's the test. And I just told you this like 5 minutes ago. What value does A and B have right now? Think about it. Don't yell at the answer right now. Take a second, think. What did James say? And then we're going to see. I'm going to do a poll. Raise your hand if you're like, yeah, I know what it is. Really high, I want to see. Really high, I want to see it. Okay. How can we test what value they have? Easy. Print it out. Go down here, code. I'm going to print A. And then none and none. Were you right? Those of you that raised your hand if you were right. Now, why is it none? Well, that's because I didn't write a return in the function no stuff. There's no return there. See, there's a return there, there's no return here. When you don't write a return in your function, Python sneaks in and adds one for you before it runs. And it adds one where it returns that special value that means nothing. That's why we see none. Whoop. There we go. There, we see none. None is that special value that means nothing. You might be thinking, though, like, well, okay, what's really the difference? Well, remember how I was able to say a plus 1 before? I was able to use the value that the function gave me back. Well, if I hit run, you can't add an integer to nothing. You can't do that. That's against the rules. Because nothing isn't the same as 0. Nothing means nothing. It's a special value that means literally nothing. It has a lot of meaning, and that meaning is nothing. Go with me on that. Questions, though? I'm certain there are some. Yeah?
So once you assign that whatever no stuff has become, which I guess is nothing,
Yeah.
to A, why are you able to print A out? Because like you wouldn't be able to print A out if you hadn't assigned anything to it.
Because we did assign something to it. Remember, nothing is actually a value, but it's a value that means nothing. So you actually get something back. It's of its own type. It's a none type. And we can test this by saying, well, what's the type of A? None type. So like an integer. An integer is a type. And what values can integers have? Well, it can have 0, 1, -1, 15, and so on. The type, none type, can only ever take on the value none. And all it means is nothing. Because you can't actually have nothing, we have to have something that means nothing. So it's a special like flag for us. What's cool about this is we can check later on, like, oh, did this function return the thing I expected? But more on that very soon. Other questions. I love this. Ask questions. It's a lot more fun to lecture when people ask questions. So everyone understands this completely, right? That's what I'm getting. Is that a question, or are you just scratching your head? Yeah, what's up?
What's the purpose of
Sorry, say that again, maybe.
What is the purpose after when you set A equal non-stop and then you open bracket? So like if you put A equal bracket 5 and 6, would that bring it out?
Well, no stuff is the name of the function. That's what tells Python, go to that function and execute the code inside the function. So that means, okay, go here and then run this code. If I don't put that there, Python doesn't know what code to run.
Do you have to delete it from the top then? Or do you have to define it first and then...
Yes, we must define the function before we can call it. Because otherwise, let's pretend I try to call the function QWERTY. It's going to say, I don't know what that is. That's not a thing. I can't go do that. But as soon as we go on and define that function, then it can go, oh, I'm just going to run that code.
And it could be any names? Or...
It could be whatever we want with the kind of the restrictions. Like it can't start with a number, and it can only have like certain symbols and whatnot. But yeah, you can call it. I mean, this isn't going to work because it doesn't exist, but that could be a valid function name. Don't ever call your function that. That's ridiculous. But it's valid. Python goes, okay, fine.
Thank you.
Other questions? Yeah?
So is return like how you put a function into a variable?
It's how you put... You're asking a question that's probably a lot deeper than you realize. The answer to your explicit question is, it's how we put the result of the function into the variable. Because that function gets evaluated, it does some number crunching, and we get a final result like the C, and then we can put it in the variable. So that's the answer to the question.
And so that's why we can like print A plus 1.
Bingo. Because A then takes on the value of 30. Why 30? Well, because that's what was crunched when we put in the 5 and the 6. And if we put in the 1 and the 2, it gets crunched to, what was it, 14 or something? What was it actually?
14.
It was 14, eh? All right, cool. But of course, no stuff's not going to work because we returned none. And then none, that's what A got. The value of A was none. And then none plus 1 is, that's not a thing. Now, funnily enough, you can actually assign, and some of you may have done this inadvertently. If you forget to assign the variables, so let's just rerun this, everything's happy. If you forget to assign the variables, Python will, it'll run that code, but you'll notice that the 30 never got printed out. That's because we never actually ran the function, because we never put parameters in there. What we ended up doing was giving like a new name to the function. So when you ask, oh, is that a way we could assign variables to functions? This is assigning variables to functions, and Python lets you do this. Not all programming languages let you do this. It's kind of a funny, neat little thing. So, interestingly enough, I can say A of 5, 6 now. Now let's do 5 and 10. And it runs 38. Why? Because A is now a new name for no stuff. No stuff and A are two names that mean the same function now. Don't do this unless you really mean to do this stuff. A lot of, I make this mistake every so often. I forget to actually give the function parameters, and then I end up not calling the function, but assigning the function to a variable. Anyways, so that's a long-winded answer to your probably a lot simpler question. Other questions? Is that a question?
No.
All right. Okay. Let me undo all this stuff because it's getting kind of crazy. There. And of course, there. All right, so do stuff, do stuff. Huh. I wonder what this is going to, it gives me 40. Well, because what's going to happen here is I say print out do stuff 22 plus do stuff 44. What does do stuff 22 give us? It tells us right there. When we call do stuff 22, it gives back the result 16. And when we call do stuff 44, it gives us back the result 24. So when I say do stuff 22 plus do stuff 44, it means 16 plus 24. That's what it means. So that's why we see the 40. Because those functions get evaluated to an actual value. Cool, right? So we can nest functions and compose functions all day long if we want. So this right here, what happens if I do this? Well, we were kind of already showing that to you. We see the none. Why? Well, that's because the function no stuff said print out C. So that's why we see 16 there. And then we say print out what no stuff returned, which was none. So we also see the none. What happens when you do this? Well, I'm just going to change this to the D. We just see the 16. Why? Because the function do stuff never said print anything out. It only said return the value. The value was 16. And then we print out 16 on that line right there. Why? Because it says print the result of do stuff 22. Print what do stuff 22 returned back. I need to stress this again. I talked about this in the lab. I talked about this on Friday. I'm talking about it again today. Print and return are very, 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 very different things. But it ends up being a huge area of confusion for new programmers a lot of time, especially when using interpreters. Because interpreters, like when using Colab, you may have noticed this happens. If I say no stuff, 5, we see 28. Why? Because we said go do the function no stuff. Then we calculate everything, and then at the end of no stuff, it says print C. So we see 28. But then we never said print out what this gave me back. But Colab is kind of tricking you when I do the following. Colab is being nice, and this niceness is leading to a lot of confusion for new programmers. Based on the code I have written here, do stuff. What we should expect to see is, okay, I'm going to go calculate do stuff. We go into do stuff. We do all that number crunching. The result of 5 was 28 before, right, when we called no stuff. But remember, do stuff never prints anything. So we return the value C, which should be 28. And then on that line of code, what are we telling the Python to do with that value? Nothing. We never told it to do anything. So Python gets the value 28 back, and then it never does anything with it. But the interpreter is doing this for you. It shows you that 28. So it might trick you into thinking that, oh, it's the return is doing like a print. It's not. The interpreter is kind of saying like, okay, look, that last line of code there, you gave me a value, and you told me to do nothing with it, so I'm just going to kind of like plop it out there for you. In a similar way that you can ask the question like 1 plus 1. That gets crunched. We did nothing with 2. We didn't assign it to a value. We never said print 1 plus 1. But the interpreter is still showing us this. Let me show you this. Let's say I do I've got 4 no stuffs. No stuff, every time I call it, it calls a print. We should see 1, 2, 3, 4. We should see 4 28s printed out. 28, 28, 28, 28. Great. If we change it to do stuff, you'll notice something like very different. We only see 1 28. A single 28. And that's because, we do the calculation for do stuff, it returns 28, we do nothing with it, that gets obliterated. The next line of code, do stuff, that gives me 28, I do nothing with it, it gets obliterated. Third line, same thing, obliterated. Last line, do stuff, it gives me back 28, that last line, I told Python to do nothing with it, and it just goes like, oh, here. Long story short, print and return are very different, even though sometimes they appear to do the same thing. Be warned. Chances are you're going to make this mistake. You probably are. It's going to happen. What you need to remember, though, is, you know what? I made that mistake, and I remember James taking more than half a lecture to talk about this weird print versus return phenomenon. Maybe I should just try switching and see what happens. Remember that. That's the key here. Remember that you might mix these up, and that's what this rant is all about. Any last questions about print versus return? I probably hit that point pretty hard, huh? All right. Let's do a quick little function here. We're getting bored. I've been talking a long time. Do a quick little function on, write a function called compmag, takes two values, gets the magnitude of the complex number. Long story short, just write a function to return the square root of r squared plus m squared. Just do that. Take a couple minutes to do this. It's going to be more interesting than having me talk at you any longer. For those of you that aren't familiar, when I have like the r with the little like up arrow too, that means like r squared. Oh no, oh wait. Don't look at the thumbnail. There. Raise your hand if you got it. A couple people. Raise your hand if you're scratching your head, because how the hell do you do square root? A couple people. Who here wants like, give me like 30 more seconds, I'm gonna get it. Okay, keep going. All right, I'm lazy. I'm just gonna do this. I'm gonna hit run. And let's say print. Who here had a similar issue? What's square root? Ah, shoot. All right. Well, you know what? Let's take a step back. Maybe we can do this in pieces. B equals SQRT of A. I know this isn't going to work, but let's at least calculate R squared plus M squared, right? Oh, I guess I'm going to want to return A once I'm done. Okay, I run it. Let's run it again. Oh my goodness. Now, okay, well, it's complaining about the square root. Okay, cool. Who here found out how to get square root in Python? How did you do it?
Have to import the math module.
Who here did square root without importing the math module? What did you do?
You get an exponent of 1/2.
Yeah, so that's the two clever ways to do it. That's easy way number one, easy way number two. For the other people, if you're saying like, oh gosh, how do I do square root in Python? How do I do SQRT in Python? Let's see. Okay, well, it's a math one. Let's see if this shows me how to do it. Well, it's saying I have to do like math. Oh, here we go. Here's an example. I need to say import math first. And then I say math.sqrt. Huh. How about that? So if we go back here, whoop. Okay, run it. So we should be in good shape. 0. Huh. Does that seem like the right answer? Anyone know what I'm doing wrong?
Exponents?
What do you mean?
I mean, aren't they supposed to be double?
So you're telling me I should do something like this. How to do power of in Python. All right, well, let's have a look. Oh, it's 2 stars. Hey, is this what you did?
Yeah, that's exactly what I did.
Wonderful! Look at that. That's the number one thing I want you to learn in this class. Google is a bit. So let's fix that. If you want to do something to the power of something, you need to use the operator star star. Why? Because that means power of. There we go. There we go. Any questions about that. Yeah,
You're printing out A, you're returning A to not B. You want something else.
you're right. Because 50, square root of 50 should not be what
It should be like 7.
5 squared is. That looks much better. Who here got that? Good job. Who here would have got it if I gave them a couple more minutes and they would have typed into Google and they would have found it? Everyone put up your hand. Wonderful. That's exactly what I want to see. There you go. If you want to be fancy, you could do this all in one line of code and have a return. That would work. But of course, who here's going, okay, but you just said import math. What the hell? Couple people, maybe? So what this means is, when you load up Python, Python's huge, right? Python is a giant programming language with a lot of bells and whistles that go with it. But chances are, every time you load up Python, you're not going to need every one of those bells and whistles. Loading up all those bells and whistles wastes a lot of time and energy and space and everything. There's no sense loading up all this stuff that you might not need. So when you load up Python, by default, it gives you a bunch of functions and operators you can use, like plus, minus, star, star. You can print. You can ask the type of stuff. You can say, what's the absolute value of something? Python gives you those things by default. But every once in a while, you're going to come along and you're going to want to do something like square root. And you know what? Square root isn't something you're using in every day, you know? So if you need to use it, you need to tell Python, okay, load up everything and also load up the math thing. Include, import all the math stuff as well, because I'm going to need to use it. Then below where we see math.square root, what you're telling Python is, from that thing I included, that math, call the function square root, SQRT. It's similar to how, like, down there in the bottom line, I say print comp meg 55. That says call the function comp meg. But I don't need to include, like, this namespace, we call it. We don't need to include, like, something dot comp meg. Because comp meg exists because I just defined it right here. It's in, like, the same file. But math, it's somewhere else on your computer. In fact, because we're using Colab, it's somewhere else in the world, literally, and we're loading it up. So there's a file somewhere on the computer that's running Python that has all the math stuff. So what you're telling Python is, okay, there's a file somewhere called math, we've imported it. So in that file, go look for the function square root and call that one. That's what that import means. One of the awesome things about programming is we don't like to reinvent the wheel a lot. That said, you're learning computer science for the first time. You're going to be reinventing a lot of wheels, but that's for the sake of learning. But once you start using these things to solve real problems, chances are someone may have actually already written the code for you. You don't need to implement every function you might ever need, because other people have probably implemented it for you. Who here's happy you didn't have to write the function square root? I am. I'm not even sure I could do that anymore. So I'm really thankful that that code exists. There's a lot of different things we can do. In Python, one thing Python is known for is how many packages and how easy it is to get these packages. There are a whole bunch of other things. There's a package called matplotlib that helps you do plots and generate beautiful pictures for plots. There's NumPy, which helps you do a lot of like heavy-duty mathematics. There's SciPy, which has a lot of functions that are very like scientifically motivated. There are a lot. Scikit-learn, that's one to do machine learning. By the end of the semester, you'll know how to do a little bit of machine learning, all because you say, import sklearn. And then suddenly you have access to all this machine learning code, and you just call a couple functions, and you can go impress everybody with your machine learning skills. It's crazy. Python's crazy like that. Anyways. All right, composition, yeah, we already saw this. Great, 72. We'll skip this for the sake of time, but I would encourage you to actually scratch this out on paper and see if you can get the result. Maybe do these two little activities on your own a little later. I've also talked about scope. before. Maybe not explicitly, but I talked about it being a thing. So if you have a variable defined inside a function, that variable only exists inside that function. There's a couple asterisks around that, but in general, it only exists inside that function. We call it a local variable. So if I say do more, so there's a simple little function that says C, like do more, it's C is 2 times A plus B, return C. That's it. Very simple. So I'm going to go back here. I'm going to reset the runtime just because I may have assigned C to some value somewhere else. I'm going to take do more. Let's delete this one. Don't care anymore. Do more, 6 and 7. And this might motivate return a little bit more. If I hit run, let's make these easier numbers. 2 and 1. Take a second, look at this code, think about what's going to get printed out. I'll give you 20 seconds to do that simple math in your head. Or somebody yell out what we should see. Yell it. Don't show me with your hands. 5. Why? Well, because A gets 2, B gets 1. 2 times 2 is 4, plus B. B was 1, that's 5. So we assign 5 to C. We return C. We should see 5. Oh, what did I do wrong? Oh, I think I'm missing an indent. There we go. 5. Great. This should not shock you in any way. At this point, you should be like, yep, okay. So, you might be saying, okay, this return business, why am I wasting my time with return? Why not just say, print C? Because C, as far as Python is concerned right now, doesn't exist. But you might be saying, C's right there. It's on line 2. I even used it in line 3 as well. Why is it telling me C doesn't exist? It's because the variable C only exists within the function do more. Think about it this way. Let's think about this code. We hit run. Okay, Python runs line 1. Okay, it's just a function definition, two parameters. Line 2, C is, okay, whatever. Line 3, another thing. Line 4, nothing. Line 5, print. So let me go back real quick here and change it back to the working version of the code. There. Because remember, when we hit run, Python doesn't really run the function definition. It just goes, oh yeah, okay, it exists, great. I'll remember that if someone ever calls the function do more, I need to go back to line 1 and start chugging through that function. That's it. That's all it really said. Line 4, nothing. Line 5. Line 5 is the first line of code that Python starts number crunching. So it says print, well, print what? Let's go inside the brackets. Do more at 2, 1. Okay, great. We go to function do more. We say, okay, A is 2, B is 1. So far, so good. Any questions about what I've said? All right, so B is 2, pardon me, A is 2, B is 1. The next line of code, we tell Python, oh, create the variable C. And assign to it the value of 2 times 2 plus 1, well, that's 5. So C gets 5. Then we say, and by the way, you have to think about how the computers work a little bit here too. There's a little bit of memory somewhere in your computer that's going, oh, okay, I'm running this function. You know, it's got to keep track of this stuff. Oh, there's a variable C. I got to remember that. Put it somewhere. So there's like a physical location within the transistors on your computer that's storing those zeros and ones. Then we say return C. Okay, return the value of C. C has 5, we return C. As soon as that function is done, as soon as we finish executing line 3, the computer goes, okay, that little chunk of RAM that we created to do all the bookkeeping for that little function, gone. It pops, it disappears. And everything about it disappears with it. There is no such thing as C anymore. Because it was defined inside the function, and that's that. Once the function's done executing, it doesn't exist anymore. Scope is going to get you. Watch out for it. Especially because you can do stuff like this. I said print C at the end. It's 44, but I just assigned it to 5. Why is it 44? That's because it's a completely different C. Even though I have two variables with the exact same name, doesn't matter. The one that was local is different from the one that wasn't local. Yeah?
If you were to tab that last line, line 17, would it return the 2 times A plus B?
I'm glad you asked this question. The answer to that is no, if I do it like this. But that's because a return tells the computer immediately stop and return. Any code that exists after a return in a function is effectively, it is absolutely 110% not ever going to run. I can have a billion lines of code under this return, it'll never run. We can have code after returns in different situations, but I can guarantee you they'll be different. None of them will look like this. But if I go here and put the return after, well, yeah. Because we just overwrote that C, but we overwrote the local C.
It's going to take the last C.
Exactly, yeah. So we said, okay, C, you're 5. C, you're now 44. Every time we call this function, what value will it always return now? 44. Everybody yell 44.
44.
Exactly. You had a question?
Can you return more than one value?
Yes. Kind of. So, in Python, you can do something like this. Okay, by the way, that 44 is still printed out because it remembers the global one. I'd have to, let's see what happens if I restart the runtime. It's because C kind of still exists even though I deleted the code. It remembers that C has a value. It's being helpful, but if anything, it's confusing us. There. And now it's saying C doesn't exist. It's because, yeah, it's gone. Anyways. So as of right now, I added a comma to that return, and it looks like it has returned 2 values. Technically, it returned 1 value that has 2 values inside of it. We returned something called a tuple, but more on tuples in like a month and a half. Many programming languages do not make it possible to even seem like you're returning more than 1 value without doing a lot of extra work. Okie dokie. You can also add optional parameters. Imagine you were doing something like this, right? I better import math because I restarted the runtime. Print, let's say 10 meters, and what was it? Okay, yeah, 10 meters. Great. You might be saying, but in the function definition, time underscore to underscore fall, it has 2 parameters. Do you see that this function, as it's defined, has 2 parameters? Well, in Python, it lets us do this really cool thing. Not a lot of programming languages do this. Next semester, you're not going to be able to do this way at least. What this says is, okay, you take 2 parameters, but the one with the equals is going to be 9.807 unless specified otherwise. So this is an example of a function that, 99 times out of 100, when we want to calculate how long it's going to take for something to fall, this is the calculation. Because that's acceleration due to gravity on average on Earth or something, right? But maybe every once in a while, you want to know how long something's going to take to fall on Jupiter. So if and when that time comes, I would say, I have no idea. Jupiter's probably huge. I don't know, 89? There. So unless you specify it like I did there, it's going to be 9.807. So here, right now, when I hit run, what value did D take? Everybody. The longer you work, or the shorter you work with me, the faster we're done for the day. What value will D have? 10. What value will A have? 89. Why? Because I specify. What value will D have? 10. What value will A have? Very good. All right. See you later.